Have you ever just stopped and watched a modern factory floor? It's it's incredible. It's like this perfectly choreographed ballet of robots and machines all moving in perfect sync. But who's the choreographer? Who's conducting that whole complex dance? Well, behind it all, there's this hidden genius called the emotion controller. It's the brain that orchestrates every single move. So today, we're going to pull back the curtain and demystify the tech that's literally powering all of modern automation.
So here's our game plan. First, we're going to nail down the core of motion control with a really simple analogy. Then, we'll meet the different families of these controllers and get to know the motors that actually do all the heavy lifting. After that, we'll zoom out to look at the huge tech ecosystems that run this industry. And finally, we'll peek into the future and see how AI is basically teaching these systems to conduct themselves.
Okay, so to really get our heads around this, I want you to picture a full symphony orchestra. You've got dozens of musicians, all with different instruments, all just waiting for their cue. Now, what stops that from becoming total chaos and turns it into perfect harmony? Well, it's the conductor, right?
And that is exactly what a motion controller does. It takes the musical score, which in this case is a program written by an engineer, and it translates it into a flood of perfectly timed commands. It directs every single part of the machine to do its job at the perfect moment in total harmony. It's really the bridge between a digital plan and the real physical world.
So let's break down the orchestra itself, piece by piece. First, you have the controller. That's the conductor's brain, making all the decisions. Then you have the drive. Think of this like the conductor's arm movement. It takes the decision and amplifies it into a powerful signal. The actuator? That's the musician. It's the motor that actually makes the sound, or in our case, the physical movement. And finally, you've got feedback. That's the conductor's ear, constantly listening to make sure every note was played just right. And this whole idea of listening is where things get really crucial. An open-loop system is kind of like a conductor who just waves the baton and hopes everyone keeps up. It's simpler, sure, and cheaper, but you can see how things could go wrong. A closed-loop system, on the other hand, is always listening. It uses those feedback sensors to hear what's actually happening and makes tiny, real-time corrections. And that is absolutely essential for the kind of high-precision work that defines modern manufacturing.
All right, so now that we've got the basics, let's meet the different types of conductors. Because, just like you'd have a different conductor for a small string quartet versus a massive Philharmonic orchestra, there are different kinds of industrial controllers, each one specialized for a different scale and a different kind of job.
So on one end, you've got the PLC. This is the reliable workhorse for simple, repetitive jobs. Think of a conveyor belt that just needs to start and stop. In the middle, you have the PAC, which is more of a hybrid. It's got PC-like power for complex tasks, like telling a robotic arm exactly where to go. And then, for the really huge jobs, like managing every valve and pump in an entire oil refinery, you have the DCS, a distributed system built for massive scale and rock-solid reliability.
But here's where it gets really interesting. These days, the lines between these categories are starting to get super blurry. Modern PLCs are getting smarter with PAC-like features. So the distinction isn't so much about the box itself anymore, but more about the software. And what this means for a factory manager is huge. You can now get the tough, reliable body of a PLC with the smart, data-crunching brain of a PAC all in one package.
So we've met the conductors. Now it's time to talk about the musicians, the actuators. These are the motors that turn those electrical signals into actual physical motion. This is where the rubber meets the road, or, well, maybe more like where the robotic arm meets the microchip.
The two big players here are stepper motors and servo motors. Stepper motors are your budget-friendly workhorse option. They're fantastic for simple, predictable jobs where you need a lot of oomph at low speeds. Servo motors, on the other hand, they're the virtuosos. They're always part of a closed-loop system, which means they deliver incredible speed and precision, especially when the job is unpredictable. You're going to pay more for them for sure, but you're paying for elite performance.
And wow, look at this. This chart tells you everything you need to know about what the industry really cares about. A massive 80% of modern systems are closed loop. That's not just a slight preference, it's an absolute landslide. It tells us that for almost every modern job, whether it's building a phone or packaging medicine, the cost of a single mistake is so high that manufacturers are overwhelmingly choosing the precision of systems that can listen and correct themselves. In this world, accuracy is king.
Okay, so let's pull back for a second. Because in today's world, you don't just go out and buy a single controller or motor anymore. You're buying into an entire ecosystem. You can think of the big manufacturers as the giant record labels of the automation world. They provide the conductors, the musicians, the software, the whole shebang.
And make no mistake, this is a huge industry. We're talking about a market that's projected to be worth over $18 billion. The stakes are incredibly high, both for the companies making these systems and for the businesses whose entire operations depend on them.
One of the giants is Siemens. They're a German powerhouse, and their whole philosophy is about total digital integration. They're famous for their digital twins. These are virtual models of entire factories. This lets companies test and perfect their processes in the virtual world before ever building a physical part. And it's all run through their TI portal, which is basically the one command center for the whole factory.
Then you've got Rockwell Automation, a huge force in the US. Their real strength is in getting tons of different machines to work together seamlessly on a complex assembly line. And a key part of their strategy is to make powerful tools like AI easy to use for the engineers on the factory floor, the OT, or operational technology folks, without them needing to be data scientists.
And listen, if you take one thing away from this section, let it be this. Choosing a controller is not just a simple purchase. It's basically a long-term marriage to that company's entire platform. The software, the training, the hardware, it's all designed to work together and only together. That vendor lock-in is very real, and switching later on is incredibly difficult and expensive.
So, where is all this going? Well, the next big leap isn't just about making controllers faster or more precise. It's about making them smarter. We are heading toward a future where the orchestra can actually start to tune itself, and maybe even learn to lead.
Just think about that for a second. What happens when a machine goes from just blindly following a set of rules to actively learning from its own performance and adapting on the fly? That's the huge shift that industrial AI is bringing to the table.
And the results? They are absolutely mind-blowing. By constantly analyzing data, AI can predict when a part is about to fail so you can fix it before it breaks. This move to predictive maintenance can slash unplanned downtime by up to 50% and cut maintenance costs by 40%. For any business, those numbers are a total game changer.
So what this really means is that these systems can actually learn and get better at their jobs. Imagine a robotic arm in a warehouse. Instead of just doing the same programmed motion over and over, it can analyze its own movements and figure out a slightly faster, more energy-efficient way to do the same task, all by itself, without a human ever touching the code.
And that leads us to one final, big question. As these incredible machines get better and better at conducting their own symphony of motion, it forces us to ask, what's the new role for us, for the human operator? Do we become the architects of the system? The trainers for the AI? The ones who set the grand strategy? That's the future that's being built right now.